Hello everyone. Today we will start with the topic real numbers and their decimal expansion. Now real numbers, it can be rational or irrational. Now how you have to understand this real numbers with the decimal expansion. Before starting this topic, we'll see the decimal expansion of three numbers given. First is 10 by 3. Here I have already noted down the three examples which has been done in your textbook. Here you have to specially take attention to the remainder and the pattern of the quotient. The first example is 10 divided by 3. Here 10, so 3 3s are 9, then 1 remaining point, then the pattern is like it is repeating, okay, and whenever you will get the remainder, it will be 1, okay. So here the quotient is 3.333 and so on. Now in further also, if you are going to divide, you will get 3 only. You have to special take attention towards the quotient and the remainder and the digits after the decimal, okay. Now here we will see the second example, that is 7 divided by 8. Now here you might be thinking, why 7.0, as 7 is less than 8. So first of all, we are going to put a decimal over here and you are going to place this 0 over here, okay. Then in further calculation you will get some 0.875. Here the quotient is terminating. Terminating means it is ending over here. Why? Because you have got 0 in your remainder, so the termination has been done over here, okay. Now you won't get any digits after this, okay. The third question is 1/7. Once again the numerator is less than denominator, so here I have taken point first and then you are going to calculate the digits. You will get some digits like 1 4 2 8 5 7, and then here it will get 1. So once again it is going to repeat this sequence, okay. If it is going to repeat this sequence, then what will be the quotient? Once again it will repeat this digits after the decimal and after the sequence of this particular numbers. So this is getting repeated. You can call it recurring also. Now we are going to analyze once again. So here in first example, the remainders are 1 1 1, okay. This is 1 1 1 and 1. The divisor is this 3. In second example, you are getting remainder 6 4 and 0. 0 means you are getting terminated. You are terminating over here, and the divisor is 8. The third example, you are getting remainder 3 2 6 4 5 1. Now if you got 1, then again this series is going to repeat. Same is for this. Here same series is going to be repeated. Again and again you will get 3 3 3, and here After this many numbers, you are going to repeat the same pattern. Okay. So here at least 3 things you would have noted. First is the remainder becomes 0 after certain stage or start repeating themselves. Okay, here the remainder will become 0 or will start repeating themselves. The second is the number of entries in the repeating string of remainder is less than the divisor. What do you mean by this? Here in the example 10 by 3, we are getting 3 after the decimal. Again 3. What is this? It is less than this divisor. Okay, it is less than this divisor. The number of entries in the repeating string is less than the divisor. Second example is 1 upon 7. There you will get 6 entries. Which are that 6 entries? 0.142857. What are these 6 entries? You can see the example in your textbook. The third point is, if the remainder is repeat, then we get a repeating block of digits in the quotient. It is nothing else but like if the remainders are repeating, then this block is going to get repeated. Here, if your remainder is going to get repeated, your this block is going to get repeated. This is to clear the rational numbers with decimal expansion. Now, analyzing the 3 steps and the 3 examples. So, on division of P by Q, 2 things can happen. The case 1 is the remainder becomes 0. The examples are 7 upon 8, 0.875. Here the remainder will become 0 at certain point. 1 upon 2, that is 0.5. 26 upon 100, that is nothing else but 0.26. In all this case, the decimal expansion terminates. The decimal expansion terminates. So, the real number which is rational, it can be terminating. So, rational numbers with the decimal getting terminated, they are also called as rational numbers. Now we'll see the second case. The remainder never becomes 0. Example 10 by 3 and 1 upon 7. Remainder repeats after certain stage. Some pattern has been seen which is getting repeated. 10 upon 3, here the 3 is getting repeated. 1 upon 7, here 0.14285 is getting repeated. Now how you can write this repeating thing in your representation? You can write 3 point, the numbers which is getting repeated, or this block which is getting repeated, you can write it over here and you can place a bar on it. Here only 3 is getting repeated. So I have kept a bar on it, on the single digit, that is 3. Here I have kept bar on 142,857. because this block is getting repeated. So here there is no end, dot dot dot, it is going to continue. So what it is called? Non-terminating. Terminating means which is completed, but here it has no end, so it is non-terminating and repeating or recurring. Okay, we will see example number 6. Show that 3.142a678 is a rational number. In other words, express it in the form of p by q form, where p and q are integers and q is not equal to 0. Simple. First we are going to take the number 3.142,678. How many digits after the decimal? First count it. 1, 2, 3, 4, 5, 6. So you are going to divide it by 1, 2, 3, 4, 5 and 6. And then you are going to write simple the number on in numerator. So what is this? This is in the form of p by q. Therefore, this number is rational. Why? It is getting the decimal after, the numbers after decimal is getting terminating. Now let us see example number 7. Show that 0.333 so on is equal to 0.3 bar can be expressed in the form of p by q, where p and q is equal to integers and q is not equal to 0. This question, I have made a short video on this question, but we will see in detail how you are going to solve this question. First of all, assume x is equal to 0.33. How many numbers are getting repeated? You can see only one number is getting repeated. So you are here, you are going to apply a trick, that is multiply 10 on both side. Equation 1 on equation 1. Therefore, 10x is equal to 10 into 0.333 dot dot. Now what is this? If you are going to multiply 10 over here, this decimal will go one digit after. Therefore, 10x is equal to 3.33 dot dot. Now what you can do? Now you have to bring this, split this. What is 3 plus 0.333? What it will be? It will be 3.33. Why you have to split this particular thing? Because I have to bring x over here. Okay. Therefore, now what is this? Here x is equal to 0.333 from equation 1. Replace this with x. 10x is equal to 3 plus x. Now doing normal calculation, 10x here minus x is equal to 3. 10x minus 1x is 9x, that is 3. Now cross multiplying, taking this 9 over here, x is equal to 3 by 9, that is 1 by 3. 3 3s are 9. Therefore x is equal to 1 by 3, which is in the form of p by q, and this is not equal to 0. Q is not equal to 0 because it is 3. So here you are just going to first see how many digits are getting repeated, and that much zeros you are going to multiply on both sides. If it would have been 0.1212, then you would have multiplied it by 100. Why? Because it is 12 bar. Now here this is in the form of p by q. In exams you are going to attempt this question like this in proper form with proper steps. Okay, we'll see the next example. Example number 8. Show that 1.272727, that is 1.27 bar, can be expressed in the form of p by q, where p and q is integer and q is not equal to 0. In previous example I have told you, if there are two numbers which are getting repeated, so you would have got an idea that here you are going to multiply it by 100. Why? Because there is 2 digits after the decimal which is getting repeated. We'll see over here. Let x is equal to 1.272727 1.27 bar. Multiply 100 on both sides of equation 1. Therefore it will be 100x is equal to 100 into 1.272727 total. Here there are 2 zeros, so decimal will go after 2 digits. Therefore 100x is equal to, it will go after 2 digits, then what will be the number? 127.2727. How you are going to split this number? Here I will give you one trick that is simple. Here the trick is simple. How you are going to separate this number? First what I will do, I will write 100x is equal to, I will leave this place 1.272727 so on. Why? Because I want x over here. So what I am going to do, I am going to minus this number from this. What it will be? 127.272727 minus 1.272727. 0.7 minus 1, that is 6 to 1. So here the number will be 126. This is the trick how you are going to do for the numbers having 2 repetition, 3 repetition. Main is that you have to find this number. Then what you are going to do? You are going to make this place blank, and you are going to minus the x number from the number which you are getting after multiplying the 100, thousands, 10, whatever. Here it is getting multiplied by 100. Okay. Now we'll continue with the example. Once again, x is equal to this. Therefore, 100x is equal to 126 plus, this is x as we have mentioned in the equation 1. This is equal to x. Now, simple calculations, 100x minus x is equal to 126. Therefore, here it will be 99x is equal to 126. Therefore, x is equal to 126 divided by 99. You will get 14 by 11, which is in the form of P by Q. This is the answer, and this is how you are going to write it in your exam. Okay, we'll continue with example number 9. Show that 0.2353535 is equal to, here see the number. Here something is different from the two previous questions. Here there is one digit after the decimal, and then the numbers are getting repeated, 2.353535, and you have to represent this in the form of P by Q. The steps are same. What you are going to do here, two numbers which are getting repeated, so you are going to multiply it by 100. Yes, we'll start with the example. Let x is equal to 0.235 is equal to 0.235 bar. Equation 1. Multiply 100. Why? 1, 2 digits on both the side of equation 1. Therefore, it will be 100x is equal to 100 into 0.23535. Therefore, 100x is equal to, now 2 digits, so it will, the point will go after the decimal. So it will be 23.53535, so on. Here the main step is this. 100x is equal to, leave the space blank, plus what you want over here, you want x. What is the value of x? 0.23535. What you are going to do? You are going to minus this digit from this, and you are going to get this number. So 23.53535 minus 0.23535, 0, 0, 0, 0, 3, 3 and 2. So what is the number you are going to add up here? 23.3. This will make easy to fetch this number. Always do this calculation. Easily you will fetch this. Just keep it blank and then minus this number from this. Therefore, now 100x is equal to 23.3 plus, this is nothing else but x. Therefore, 100x minus x is equal to 23.3. Therefore, 99x is equal to 23.3. Therefore, x is equal to nothing else but 23.3 upon 99. You are going to take this decimal in the denominator. What it will be? 233 upon 990. This is nothing else but 0.235 bar, which has been brought in P by Q form. P and Q are integers and Q is not equal to 0. Okay, here there are two numbers, rational and irrational. Now you are going to bifurcate. You are going to see the definition considering the decimal. The decimal expansion of a rational number is either terminating or non-terminating but recurring. So a number whose decimal expansion is terminating or non-terminating recurring, both the forms are called as rational. Means they can be represented in the form of P by Q, where P and Q are integers and Q is not equal to 0. The second is the decimal expansion of irrational number is non-terminating and non-recurring. Means we have seen the rational numbers. In irrational, what it will be? The numbers after decimal, they will not terminate and they will not repeat also. There will be no pattern in it. They are not going to terminate and they cannot be represented in the form of P by Q. So, a number whose decimal expansion is non-terminating, non-recurring is called irrational number. Now here irrational numbers are example given in your textbook are root 2, 1.4142 and so on. This number is not going to terminate. It will have numbers repeated, not repetition, no repetition. It will not terminate and it will not repeat even. There will be no repetition. The pi, here pi is equal to 3.141592, so on. In calculation, you take pi is equal to 22 by 7, but that is not, pi is not equal to 22 by 7. It is roughly you have taken to calculate some nearby digits after the decimal. Okay. Now in example 10, find an irrational number between 1 upon 7 and 2 upon 7. How you are going to fetch such numbers? Here simple, what you are going to do? First you are going to take out 1 upon 7. In your example 5th, you already have find out it is 0.142857. Okay, this is rational number, but you have to find irrational number. Now this is starting point, ending point is 2 by 7. What is this? This is nothing else but 2 multiplied by 1 upon 7. So this is nothing else but 2 multiplied by 1 upon 7. This is 2 multiplied by 0.142857. What will be the number? It will be 2 4s are 14, 2 7s are 14, 1 7 5 8 2.0. This is also rational and this is also rational. Now what you have to find out? You have to find an irrational number. Irrational number is non-terminating plus non-repeating. So any number you can write between these two numbers. So it can be 0.15. Yes, it will come 5, 1, 2, 1, 1, 0, 1, 1, 2, 3, 1, 1, any number, but it should be non-terminating and non-repeating. And the answer for such question, for irrational, finding an irrational number between this, can be different for everyone. You just have to consider two situations, two things to be satisfied, that is non-terminating and non-repeating. And here the boundation, the boundaries, here 1, 4, so you can take 1, 5. It is coming between these two, and then you have to write any number which is not getting terminated and it is not getting repeated even. So you are going to attempt such questions like this, and you are going to write any number which is non-terminating and non-repeating. In exam simple, you are going to write that this is the, you are going to find first this number and then the endpoint, and you are going to take the two numbers with you, and then you are going to write a number which is not terminating and non-repeating even. So if you do like my video, please like, share and subscribe. If you have any doubts, any question, please write in my comment section. Thank you. Have a nice day.